Great. So bone matrix, that's what the bone is made out of. And this is mostly hydroxyapatite, which is 65% of the bone, calcium ions, phosphate, and hydroxide. Then there's collagen. Does anyone remember what collagen is from yesterday? Because I know I mentioned it yesterday. You can type it in chat if you know the answer.
Wait,
Yeah?
it's like, isn't that what your either ears or nose out of?
That's close, yeah. So yesterday I was talking about cartilage, hyaline cartilage, elastic cartilage, and fibrocartilage. So those are made out of collagen. Collagen is a structural protein, and it's also found in the bone. It makes up 10% of the bone. And I think I mentioned, yeah, I think I mentioned yesterday that.
Wait, how do you spell that again? The protein thing?
Oh, collagen. It's the thing over here. I think I can use a pointer. Yeah, it's this thing.
Okay, thank you.
No problem. So there's 3 types of structural proteins: collagen, elastic, and reticular fibers. Collagen is the strongest one out of them, and that makes up 10% of the bone. And then there's 25% water, which I hope you guys all know what it is. So yeah, bones aren't dry. You can record this information down.
Which slide are we on? Because I had another class, so I missed some of it.
This is slide 3.
Okay. Will you post it on Google Classroom after this again?
Yep, I will. And there will also be a recording like yesterday. Okay, so does anyone have any questions? You can ask it. Yeah, sure. Ca2+, that's calcium ions. And calcium ions are found in the bone. Yeah, so that's why they people say you should drink milk to get stronger bones, because milk has a lot of calcium in it. And the plus sign, so I don't know if you guys ever learned chemistry before, but a lot of elements on the periodic table, some of them they'll have charges sometimes, and like I guess based on their position on the periodic table, it can tell what charge they have. So calcium usually has a 2+ charge. Oh yeah, I'm gonna move on. If you haven't finished copying, I'll post the presentation on Classroom later. So, oh, this is bone structure. Does anyone know what type of bone this is that we learned on Tuesday?
Long bone. Long bone.
Yeah, it's a long bone. So the long bone has an epiphysis and a diaphysis. Diaphysis is this long shaft down the middle. It's this thin part. And the epiphyses are the edges, these 2 parts. So this is the proximal epiphysis. It has this chunk of bone sticking out, and distal epiphysis just like this. And then on the inside of the bone, you have spongy bone. Do you guys remember what that is? Oh yeah, bones with holes. It's a pretty accurate description. And you have compact bone on the outside. So on the very outside of the bone, there's a layer called the periosteum. This is like this strong and tough layer, and it's supplied by blood and nutrients and nerve cells, which you can see over here. These are the arteries that lead to the bone. And then on the inside, you have a medullary cavity. It's like this hollowed out tube on the inside of the bone, and this contains yellow bone marrow, which we'll talk about later. There's an endosteum, which is a layer. It's more sensitive, and this surrounds the inside of the medullary cavity. Any questions? So the holes in the spongy bone, which is also called trabeculae, that it holds a lot of red bone marrow, which we'll learn about next. I did go through some basic functions of red bone marrow on Tuesday. Do any of you guys remember that?
Red bone marrow contains red blood cells.
Yeah, and it also produces red blood cells, which is great and very important for your body. Oh, so you see over here, there's like this line over here. That's called the epiphyseal line. It separates the epiphysis from the diaphysis. And you guys probably don't have an epiphyseal line yet. You have an epiphyseal, okay, sorry my pronunciation, epiphyseal plate. And that is where growth takes place in long bones. So since you guys are most likely still growing, you guys have a plate and not a line yet. But once you become adults, then you'll have this separation over here.
I have a
Oh,
question.
so, yeah.
Before the medullary cavity, what is that like? That I think like covering here.
The covering around the medullary cavity,
Yeah.
that's the endosteum.
Okay.
It's,
Thank you.
yep, no problem.
Can you scroll down a little bit?
Okay. So how much time do you guys need on this slide?
One or two more minutes.
Okay. The bone marrow and, yeah, red bone marrow and yellow bone marrow are next. The bone matrix slide? Yeah, sure. Oh, the letter I on the handout sheet. I'll post a key to that later so you guys can see if you missed something. And I'll also post a presentation on Classroom. Okay, is everyone ready to move on?
Yes. Yes.
What are we supposed to write for the bone layers?
There's periosteum and endosteum. So periosteum is the layer on the outside. This is like the tough layer, and it's supplied with blood vessels and nerves. And then the endosteum is the layer, it's more sensitive, and it surrounds the medullary cavity. So you know endo means inside, so it's on the inside of the bone.
Like, could you repeat that again, like a little bit slower?
Yeah, periosteum, the outer layer, it's stronger and also supplied by blood vessels and nerves. So it's on the outside of the bone.
Wait, supplied with,
Blood vessels and nerves.
okay.
Okay, and then you have endosteum. It surrounds the medullary cavity, which is this hollowed out tube on the inside. Endosteum, it's more sensitive.
Wait, how do you spell what it, how do you spell medullary?
Medullary.
Okay, thanks. Surround the medullary cavity.
Yeah, the words on here are kind of small, but it's all. Okay, so I'm going to move on. We have bone marrow. There are two types of bone marrow, red bone marrow and yellow bone marrow. So red bone marrow, as you guys, I hope you
Blood
can,
cell production.
yeah, blood cell production. And so you have erythropoiesis, which is the production of red blood cells. And then they also produce white blood cells and platelets. Does anyone know what white blood cells do?
They're
They
like
fight
part of your
disease.
immune system.
They
Yes.
fight viruses.
They fight diseases and viruses that enter your body.
Yeah, that's correct. And then, does anyone know what platelets are?
They help
When
clot
you get
blood.
cut, platelets
Yeah.
cover the wound so that bacteria doesn't
Blood
get
clot.
inside.
Yeah, they're the blood clotters.
Mm-hmm. And then you also have maturation of immune cells in the red bone marrow. The red bone marrow is found in spongy bone, which you can see in this picture. And that's what the holes in the spongy bone are filled up with, I guess. Okay, and then you have yellow bone marrow. This marrow is found in the medullary cavity, which I mentioned earlier. And it's for fat storage, so that's why it's yellow, because fat is kind of yellow. And it also contains mesenchymal stem cells, which are for bones, fat, and cartilage, and muscle cells. So mesenchymal cells, they're like, they're the stem cells. They can differentiate into different other types of cells. So they're like the very basis of all cells, kind of. And yellow bone marrow can also store minerals like calcium and phosphate, which, if you guys remember from the bone matrix slide, that is what makes up hydroxyapatite. So those minerals are pretty important for your bones. Red bone marrow forms blood cells. So like red blood cells, white blood cells, those kinds. Yellow bone marrow is for fat storage, and it also stores minerals like calcium and phosphate. And then it contains mesenchymal stem cells. These are undifferentiated cells. They can become other cell types, like for bone, fat, cartilage, and muscle cells. And then yellow bone marrow is found in the medullary cavity. Actually, most people aren't born with that much yellow bone marrow. You get it over time. So like once you eat a lot of food and you start growing, then your bones start storing up this fat. Red bone marrow is for blood cell production. This is like erythropoiesis over here, which is the production of red blood cells. And it also produces white blood cells, which are for immune response, and platelets for blood clotting. And then it also has the maturing of immune cells. So immune cells, they go to the red bone marrow and they mature there and they go out into the blood. What if yellow bone marrow malfunctions? Well, I guess if you don't eat enough food, then you won't have a lot of yellow bone marrow. I don't really know about malfunctioning. Okay, so is everyone ready to move on? Okay, so review on what bone marrow does. Do you know which bone marrow does blood cell production?
Red bone cell, red bone marrow blood cell production,
Yeah.
immune
Bone marrow.
Yeah,
Immune cell maturation. Inside medullary cavity for yellow bone marrow.
Uh-huh.
For yellow bone marrow.
Immune cell maturation for red bone.
Okay, great. Okay, so this is the structure of compact bone. Just wondering, does anyone remember how much mass compact bone takes up inside an entire bone?
10%.
80.
10%. Yeah, it's 80%. So
Wow.
even though spongy bone fills up the entire interior, compact bone takes up a lot of mass because it's like dense and everything. So compact bone is made up of osteons, which are like these cylinder shaped. These are the structural units of bone, and they're made up of lamellae, which are these concentric circles inside the osteon. So you can see in this picture. So the very middle of the osteon, it's hollowed out, and this is where the central canal goes through, and this contains all the blood vessels and the nerves. This is what supplies your bone with nutrients. Then you can see how some blood vessels and nerves are going perpendicular to the osteons. These are called Volkmann's canal, and these like go through the bone instead of down the osteon. Any questions? Can I repeat? Okay, so osteon, this is what makes up your compact bone. It's the structural unit of your bone, and it's made up of lamellae, which are the concentric circles inside the osteon. Oh yeah, this is called the Haversian system. It's spelled as Haversion. So I think that's on the handout.
What is the word starting with H on the handout? I couldn't hear.
Haversian. I'll type it out in the chat.
You repeat it all again a little bit more slowly because I didn't get it all.
Sure. Okay, so this is compact bone, the dense part of your bone in the outside. And it's made up of osteons, which are the structural units of bone. So these are like cylinders that go through your bone. And these are made up of lamellae, which are these concentric circles on the inside of the osteon.
How do you spell lamellae?
It's over here, Lamellae.
Okay.
And then the middle of the osteon is hollowed out, and this is where the central canal goes through. So central canal that holds all the blood vessels and nerves, and this supplies your bone with all the nutrients that it needs. Oh, the word starting with V, that is Volkmann's canal. I'll spell it out in the chat.
Volkmann.
And so this is the blood cells that go perpendicular to the osteons. Okay, so you can see the dots that cover all the osteons. And if you zoom up, this is what it looks like. This is called a lacuna, and it contains osteocytes, which we will learn about later. And it's a bone cell though. And these are held inside the bone with canaliculi. These are little thread-like fibers. They hold the lacuna in place. Yeah,
I'm
kind of.
looking to move on.
I like to think of it as a spider, though. Yeah, we'll learn about that later during bone repair. But when you break a bone, the blood cells actually rupture. Sorry, not blood cells, blood vessels. The central canal contains blood vessels and nerves. Okay, so does everyone have this copied down?
Yes.
Yes.
Great. So types of bone cells. There are osteoblasts, osteocytes, and progenitor cells. Osteoblasts, they're bone matrix. They're what secretes down all the bone matrix and stuff. It builds your bone, it makes it grow. Osteoclasts, they're the antagonists of osteoblasts. They break down your bone and they release all the calcium that's stored in your bone into your blood. Then you have osteocytes. These are actually matured osteoblasts, and these control the osteoblasts, and they work in bone maintenance so that you have healthy bones. And progenitor cells are the cells that produce osteoblasts.
I
So you
didn't
can
get the part about the secrete.
Yeah, we will. In the next few slides, I'll go more into detail on all these cells. So you can see on the bottom, you have osteoprogenitor cells. They're the precursor to osteoblasts. Then osteoblasts mature into osteocytes, which are the cells inside lacuna.
Can you repeat what osteoblasts secrete?
I'll go into detail on the next slide.
Okay.
Wait, can you not? Can I just copy this down for a second?
But I'll repeat this. So osteoblasts, they're bone makers. They help your bone grow, and they secrete bone matrix, which I'll go more into detail on what they secrete on the next slide. Then osteoclasts break down bone, so they release calcium into the blood while they break down this bone. Then you have osteocytes. They're the matured osteoblasts, and they work in bone maintenance, so they control osteoblasts in their activity. And then osteoprogenitor cells, they are the precursor to osteoblasts, and they will become osteoblasts later on, which you'll see in this. It's kind of like a time cycle.
What do osteoblasts boost activity? So one of the questions says dash boost activity for osteoblasts.
Oh yeah, that's on the next slide. So if you guys are all done copying down this slide, it's like the basic overview.
Yeah.
Oh, so now osteoblasts. They secrete osteoid, and that is what makes up the bone. This is unmineralized bone matrix. So you have that secreted, and when it mineralizes, it becomes your bone, your actual bone. Calcitonin, this is a hormone that is secreted by your thyroid gland, and this boosts osteoblast activity. So basically, the body, they monitor your calcium blood levels, and when they realize, oh shoot, the person has too much calcium in their blood, then the body secretes calcitonin, and then this boosts osteoblast activity. They use the calcium in the blood to create more bone. And so if you eat a lot of calcium-rich foods, then your blood will have high calcium levels, and your bone, your osteoblasts will work more, and that's why you grow if you eat more calcium. So you guys should all drink milk. It's very high in calcium.
But I just did.
So your body, it likes to maintain a certain level of balance throughout your entire body. So when there's too much calcium in your blood, then they secrete calcitonin to get rid of that calcium in the blood, to use it up. And sometimes if your hormones aren't working properly, then you won't have the osteoblasts. They don't get stimulated, and you have too much calcium in your blood, which is actually not good. Yeah, secrete means it releases. Does everyone have this down?
Yes.
Yeah.
Yes.
Okay.
Wait, next is osteoclasts, right?
Yeah. Next we have these secrete acid phosphatase, cathepsin K, and a bunch of other stuff. And this is all to help break down the bone. So osteoclasts, they're stimulated by parathyroid hormone, which is short for PTH. And PTH is secreted by the parathyroid. So this boosts osteoclast activity. So when your body senses that there aren't enough calcium ions inside the blood, then it tells the parathyroid to secrete parathyroid hormone. So osteoclasts will start breaking down the bone and releasing all the calcium that's stored inside your bone. So even though they're antagonists, osteoblasts and osteoclasts actually work together in order to maintain your bone structure. So osteoblasts, they secrete this thing called RANKL, RANKL, and this allows for differentiation of osteoclasts.
I have a question.
Yeah?
On the osteoclast note page, it says osteoclasts are bone something.
Or bone breakers.
Oh.
Yeah. They break down the bone with the stuff that they secrete, and
Why would
this
they break?
calcium into the blood. So rank L is this thing secreted by osteoblasts. It's a differentiation factor. And so without rank L, your osteoclasts wouldn't be able to work. So even though they're antagonists, osteoblasts and osteoclasts work together. Does everyone have this written down?
Yes.
Okay. I'll wait for
Yes.
like a few more seconds.
What is RANKL again?
What?
What is RANKL again?
Oh, this is a differentiation factor. So this is secreted by osteoblasts, and it binds to a bunch of other stuff to allow for differentiation of osteoclasts. So without rank L, your osteoclasts wouldn't be able to work.
Can we move on?
Yeah. Osteoclasts are important in bone structure because, which we'll learn about later, in bone turnover, which is controlled by osteocytes, your bone is constantly being renewed. So it's not just always your same bone for the rest of your life. And it also releases calcium ions into the blood when there isn't enough calcium. So osteocytes, they're what is inside lacunae. Does anyone remember what that is?
Where it's located inside the cranium.
Yep, it's part of the Haversian system. They're like these cavities that hold the osteocytes, and they're held up by canaliculi. So osteocytes secrete hydroxyapatite, calcium carbonate, and calcium phosphate. And they're they secrete hydroxyapatite, which is part of the bone matrix. Hope you guys remember that. Calcium carbonate, calcium phosphate. And then osteocytes are responsible for bone maintenance. They control osteoblast activity to make sure that your bones are always healthy.
What?
Osteoblast activity. They control osteoblasts.
Can you like not switch the slide for a second? I just need to do something.
And there's something at the bottom that says osteoblast
What?
And there's something at the bottom that says osteoblast
I'll check that later. But osteoblasts, just a reminder, they're bone makers.
No, but under bone maintenance, there are blanks, and then it looks like Spanish with that accent mark.
It says EX bone turnover.
Oh. Okay, I don't really know. I don't know what that is. It's probably a typo or something. Or maybe I typed this document in Word, so maybe it had like this weird thing when copying and pasting. Okay, so I'm going to move on to the next slide.
Wait 1 second.
Okay. Okay, I'm gonna move on, and I'll post the presentation on Classroom, so don't worry if you didn't record anything. Bone cell review. So what's the answer to number 1?
Osteoblast.
Build.
Build bone.
Osteoblast.
A.
They build bone. Parathyroid hormone boosts osteoclast activity. Is that true or false?
False.
That's actually true. Parathyroid hormone boosts osteoclast activity, and calcitonin boosts osteoblast activity. Yep. So rank L does what?
C.
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 That's correct. And then where are osteocytes?
And B, I think.
B. Lacunae.
B.
Uh-huh.
Lacunae.
Okay, great. Guys, remember this? So bone repair. What happens when you break your bone? You have to wear a cast for a really long time, and it's painful. But at the molecular level, so you have step 1 is a formation of a hematoma. So when you break your bone, as you remember from learning the Herbertian system, there are blood vessels that go through your bone. And so these blood vessels, they fracture when your bone is broken. And this means that blood is all pouring out. And this forms a hematoma, which is basically clotted blood. And the bone cells without nutrients, because they're not supplied with blood vessels anymore, they all die out. So that's the first step. And this takes usually 1 to 5 days.
I don't get. Can you repeat that?
Yes. Yeah, so when you break your bone, the blood vessels inside your bone, they fracture. And then this means that like the blood vessels, they're broken, there's blood pouring out. And this forms a hematoma, which is clotted blood. And then because blood vessels, they supply your bone cells, When your bone cells don't receive any more blood, they die out because they don't have any nutrients left. Oh, this is 1 to 5 days for the first step. It takes
Wait,
a
so
lot
the-
longer for your bones to repair.
Wait, so the first step is not actually repairing, right?
No, this is just like what happens when your bone breaks. I mean,
Okay.
I guess formation of clotted blood is kind of repair because then your blood's not just like pouring out. Okay, so then step 2 is formation of a cartilaginous callus. And this is when new blood vessels, they invade your bone and they form inside the hematoma. Then dead cells are all cleared out. The dead cells are the cells that died because lack of nutrients. And then fibroblasts. These are cells that secrete collagen. Does anyone remember what collagen is? I mentioned this like 10 minutes ago. So
Collagen is like what makes up cartilage.
yeah, and what makes up bone matrix. Takes
So
up,
like a protein.
yeah, it's a protein. Takes up like 10% of the bone matrix. The fibroblasts and osteoblasts, the bone builders, they start and they secrete a bunch of stuff to start forming new bone. And this develops a fibrocartilaginous callus, which is made out of fibrocartilage and hyaline. Do people remember what fibrocartilage and hyaline are? Oh, so basically fibrocartilage is it's the strong cartilage and it's found in the meniscus of your knee. And hyaline is the most abundant cartilage. It's found in all of your synovial joints. These cartilages are made out of collagen. Okay, so then I'm going to repeat step 2. That's formation of fibrocartilaginous callus. The new blood vessels form inside your hematoma, which is the clotted blood formed on the first step. Then all the dead cells are cleared out. And fibroblasts, which are cells that secrete collagen, and osteoblasts, which are the bone builders, these guys work together to form new bone. And this develops into a fibrocartilaginous callus. No, we're not going to play Scriblio today, but if we have time, we're going to play Quizlet live.
Yeah, okay.
Fibrocartilaginous callus. This is a callus, which is like kind of like a bump thing. It's made out of fibrocartilage and hyaline, which are the cartilages that we learned about last week. You can review your notes if you don't remember what that is. And this is like the second step to bone repair. Okay, so third step is the formation of a bony callus. The fibrocartilaginous callus, which was originally made out of cartilage, becomes bony. So it has spongy bone now.
Move on.
What?
Never mind.
Okay. And after that, which is remodeling, which can take many years, which is why you have to wear a cast for a really long time after you break a bone. So these remodeling is done by osteoblasts and osteoclasts, and I'll go on to that on the next slide. Oh, step 2. It takes 5 to 11 days. And this is the formation of a fibrocartilaginous callus. So the hematoma, which is clotted blood formed on the first step, new blood vessels form inside of it, and all the dead cells are cleared out because the cells died without nutrients. Fibroblast, which is a cell that secretes collagen, and osteoblasts, which are the bone builders, they form new bone. And this new bone is the fibrocartilaginous callus, which actually isn't bone yet. It's made out of fibrocartilage and hyaline, so it's not actual bone yet. It becomes actual bone on the third step. Cool, so does everyone have this down? Are there bones that take different amounts of time? Well, I don't know about the different types of bones, but I'm guessing that the worse your fracture is, the longer it'll take to heal. So like if you get a hairline fracture, which is just like a little crack down your bone, it doesn't take that much time to heal. Sometimes you don't even need to wear a cast because you don't have to hold your bones in place. But then I guess if your bone snaps completely in half, then that would probably take a decent amount of time to heal. A transverse fracture. That's cool. We'll learn about all the different types of fractures tomorrow. Remodeling. I'll go more into detail with that on the next slide, but remodeling, it takes like really long. Sometimes it can take years, and it's remodeled with osteoblasts and osteoclasts. Yeah, don't break your bone. It hurts a lot.
Wait, are we only gonna do like skeletal system?
Tomorrow is the last day of skeletal system. After that, you'll get to learn about the muscular system, which in my opinion isn't as good as the skeletal system. And then you'll get to learn about the integumentary system.
Oh, okay.
Integumentary is also my favorite.
Wait, integumentary is skin, right?
Yeah, skin and all the accessory structures.
In hair and nails.
Mm-hmm. Cardiovascular system isn't the system next here, so we're just learning these three. Okay, so I'm gonna move on to the next slide, which is about remodeling. So bone remodeling and bone turnover. Remodeling is basically osteoclasts and osteoblasts just going back and forth. Osteoblasts, they break down all the excess bone on the exterior and in the medullary cavity, and osteoblasts add new bone. So even though these guys are kind of like working against each other, they do cooperate. As you can tell from before, osteoblasts, they secrete rank L, so they're important for osteoclast activity. And osteocytes control all these activity, all like the overall activity, and they can stimulate the secretion of parathyroid hormone, which, if you guys remember, that is what it boosts osteoclast activity. So more parathyroid hormone means more bone breaking. So it's weird because if you break your bone, you have osteoclasts working, which breaks your bone even more. Pretty cool. And then next is bone turnover, which is basically remodeling, except it works for you through your entire life, and this is controlled by osteocytes. So osteoclasts are always breaking down the exterior of your bone, and osteoblasts are always adding new bone. This is like, sometimes it's because of fluctuations of your calcium blood levels, and your bones, they're not just like always, you don't grow bones and then they stay like that forever. There's always activity going on. And so bone turnover, yeah, it's controlled by osteocytes. And fact is, elderly people, they have increased PTH levels, which is parathyroid hormone. And this results in excessive bone turnover because osteoclasts are always working. And because of all the osteoclasts breaking down the bone constantly, this results in weak bones. So old people sometimes have osteoporosis, which is basically bones they break very easily.
Wait, osteo what?
What?
Wait, what's the condition?
Oh, osteoporosis. This is like you have brittle bones because they're being broken down by osteoclasts and sometimes other factors too.
They're being broken down faster than being added.
Yeah, exactly.
Okay.
Remodeling and bone turnover. So remodeling is, I guess, what happens when you break your bone. So you have your bone cells, they're fixing up your bone that just broke. So I guess if you have a bony callus, it's kind of like you have excess bone on the outside, and then your osteoclasts, they break it down. Then osteoclasts accidentally break down too much, so then your osteoblasts add more bone, and it's like a constant going over to perfect your bone. And once bone remodeling is done, then you have continued bone turnover, which is, I guess it's kind of the same thing, except bone turnover, it's in everyone. It's not just because you broke your bone. By the way, I'm thinking if you, I guess if you turned in some questions on the Google form, I'll answer them later anonymously on a Google spreadsheet. So.
Wait, will we have homework?
Homework? There's homework on Friday. It's like this, it's a practice test on a Google form. You guys can take it.
Oh, is it like a review of like the system?
Yeah, it's a reviewing the skeletal system. And
Okay.
I recommend you don't cheat on it, even though you can.
Wait, can you post today's slides so we can also study for it?
Yeah, I'll post everyday slides after the class.
Okay, thank you.
No problem. Oh, so I'm gonna move on. We have Quizlet Live.